Hi everyone, welcome to another tutorial about network troubleshooting. In this tutorial, I'll show you the Windows variant of IFCONFIG, and that's ipconfig. Right, so because I'm on a Mac system, I just open Windows in VirtualBox, which I already have here in the background, and this looks like I'm on a Windows system, so I'm virtualizing the Windows operating system onto my Mac. Right, so to run ipconfig, we'll need to open command prompt, and you can find this in start, run, and then here you can simply type in cmd, and voila, command prompt pops up. Right, so knowing how to get around command prompt is quite handy, as you can easily identify and resolve many issues for the average user. And in this case, ipconfig could be used in lots of ways, but the most used way would be when you use it like this: ipconfig/all. And this should show all the TCP/IP details for all your physical interfaces. You can see details such as the IP address, the mask, the MAC address, the default gateway, and so on and so forth. Right, so let's run it and see what we get. Right, and there you go. This is a standard output. As you can see here, the first heading is my Windows IP configuration, and afterwards we have details about each network interface. I'll talk about the configuration and the first network interface, and the details should be similar for all the remaining interfaces. And now let me quickly run you through this. We have hostname, and this is Edward. This is virtually the name of the computer as seen by the network. Then we have primary DNS suffix, and here most small LANs don't have a DNS server set up, so you probably won't use a DNS for name resolution. Afterwards you have node type hybrid. Right, so virtually the node type section tells us how this computer identifies the address of another computer on the LAN, and usually broadcast is the best setting for a small LAN, although anything but peer-to-peer will work. But please pay attention: if you don't have a Winserver and you see peer-to-peer here, then you have a problem. And in case you're unsure what a Winserver is, this is just a name resolution protocol that's still widely used in the industry, because it provides a dynamic NetBIOS name to IP address database, or in other words, it basically offers a central mapping of host names to network addresses. Right, so whenever you see a node type as mixed, this is also called as an M node. This will work on a small LAN, but it may cause response issues when trying to resolve invalid names. So if you see hybrid here, it tells us that Wins is in use. And the hybrid mode simply tells us that the client-side resolver uses Wins first when attempting to resolve a single name query. And if it can't resolve it, then it will try to broadcast to resolve it. Of course, this is only after DNS resolution fails, since DNS is used first anyway. And the client-side resolver will suffix the search suffix when attempting to resolve it as a DNS hostname query. Right, so moving on, then we have IP routing enabled, and in our case is no, and this basically means that the RRAS is not installed. The RRAS is virtually routing and, I believe, remote access services, and this is basically a suite of network services in the Windows Server family that allow your server to perform the tasks of a conventional router. Afterwards, you have Wins proxy enabled and is set to no in our case. And a Wins proxy is a Wins enabled machine that helps you to solve name queries for non-Wins enabled machines in our current TCP/IP networks, right? Afterwards, we have DNS suffix search lists, and this is set to home. This is what the client-side resolver uses when it attempts to resolve a single name query, right? So this here is our Ethernet interface currently in use. We have a connection specific DNS suffix set to home as above here. And this is because most machines do not really support or use more than one name in DNS. But at times you might find some usefulness when you decide to configure multiple connection specific DNS names. For instance, if you decide to use multiple names, you can specify which network connection to use when clients connect to a multi-home computer, right? So then we have the description of the adapter. Afterwards, we have the physical address as shown here, and this physical address is just a MAC address for this network card, and this is usually unique if it's set by the vendor. And this is so because vendor assigned addresses are unique, and that's the case for every device in the world. Although users can define this address, but you need some tools to do that, and I think you can get these tools from the vendor, or you can access and set the device properties wizard within Windows. I'm not a Windows user, so I'm not really sure where those are, but I believe they are in the local area connection properties. Right, moving on. Then we have DHCP enabled, and that is set to yes. So if DHCP is enabled, it means this computer should get its IP settings from a DHCP server, right? And that's just a dedicated server running the DHCP service, right? And if auto configuration is enabled, which it is in our case, this computer got its IP settings from the DHCP server. If DHCP is enabled, as shown above, but auto configuration is not enabled, it means that a DHCP server was not available, right? So then we have the link local IPv6 address for that interface, and we see that this interface is IPv6 enabled. Usually the prefix for these start with FE80 for the link local ones, right? Afterwards, we have an IPv4 address unique for each machine. And as you may already be aware, taking the IP address and the subnet mask from here, and if you try to subnet the IP address, we see that this subnet is 10.0.2.0, right, /24, because only the first three or the first, should I say 24 bits are set in the subnet mask, right? And the host address in our case is .15, right? If we're on a LAN segment, all hosts must have the same subnet, and all computers must have a different host address. Well, I guess it makes sense, right? Then we see the lease obtained and the lease expires. And that's my DHCP lease. When we connect to a DHCP server to ask for an IP address, this IP address usually it's leased, and the server virtually tells you how long you can use that particular IP. In our case, this should usually be a 1-day lease, and it is. Right. Right. So by using the subnet, right, the subnet and the host addresses together, we determine which computer on a LAN can communicate. Then we have the default gateway, and this determines if the computer can communicate with any hosts outside the subnet. The default gateway must be the IP address of another host on the same subnet, but this also connects outside the LAN. With no default gateway value or with an invalid IP address here, your computer won't have access outside the LAN, right? So then we have the DHCP server, and this identifies the network device that issued the IP settings for this machine. And it's worth mentioning that any host configured for DHCP will attempt to secure a lease from a DHCP server when the network interface comes online, as we have seen with the lease obtained and lease expires messages. Right. DHCP v6 server, next here. This is a DHCP server for IPv6, right? And it has a host identifier named DUID, and this is device ID or device UID. And this device UID is used by a client to get an IP address from a DHCP v6 server, right? And here we have IAID, and this is an identity association identifier, and this association identifier identifies uniquely that interface on our system, right? Then we have DNS servers, and this happens to be in my router. It has my router's IP address 192.168.0.1. Last, we see that NetBIOS over TCP/IP is enabled, and let me just say a bit about NetBIOS. Any NetBIOS enabled machine broadcasts their NetBIOS machine name, usually every 60 seconds, saying, hey, my computer name is Edward and I have this IP address. And this is usually used for file or printer sharing. And as far as I know, on Windows, NetBIOS is used primarily to allow you to discover other computers on your subnet or in the same domain. And when this is disabled, virtually the computer cannot use broadcasting to discover what's around them, and then you must rely solely on other resolution methods, right? So at the bottom here we have some tunneling adapters, and these are used to secure communications across an untrusted network such as the internet. And these adapters are part of the Microsoft implementation of the IPv6 address, and you will find you have quite a lot of them, as in our case here, at least one per each defined network interface. In our case, we have tunnel adapter ISA tap.home. I can't remember what ISA tap stands for, but I know this is used to help enterprise to make the transition to an IPv6 infrastructure, and know that this adapter encapsulates IPv6 packets by using an IPv4 header, right? So again, it allows enterprises transition from IPv4 to an IPv6 infrastructure, and that will occur gradually in the future. Right, let me give you an insight in another type of network adapter, and that's our Teredo tunneling pseudo interface here. And a Teredo tunneling adapter is just a virtual entity that acts as a translator between IPv6 and IPv4 networks. Because at the moment most of the internet is connected using IPv4, we don't really have a native or a direct connection to IPv6 networks. And this is where this Teredo tunneling steps in, because it gives us the ability to create communication between IPv4 and IPv6 networks. And this is just an interpreter to create a bridge between these two types of networks. And in layman terms, it's just a, I should say, a translator or slash interpreter between someone who speaks Chinese and someone who speaks Japanese, let's say, who knows both languages and enhances communications between parties. As far as I know, this was developed as a temporary solution, and I believe it will be dismissed when IPv6 becomes native in the internet. Right, so that's it for ipconfig. I hope this was useful for you. It's quite comprehensive, I know, as it goes to a lot of detailed stuff. But if you want to read more about the specifics, feel free to do that. I hope you have enjoyed this. Don't forget to subscribe, and I'll see you in the next video.